Hello. Good afternoon, everyone. So my name is Vlad Zhukov. I'm Director of Engineering for Amazon Sagemaker. Sagemaker is our machine learning platform with the main goal of making adoption of machine learning easier for the companies. And we've been working closely with few strategic companies in early adoption that help us to move product forward. And I'm really happy to introduce today Zalando, who's worked very, very closely with us, and KK, who is Vice President of Data Science and Machine Learning, will explain to you how SageMaker helped them to move their machine learning forward. KK.
All right. Hi, everybody. Can you guys hear me in the back there? All right, good. So I'm KK, Kshiji Kumar. Where's the clicker? Is this the clicker? All right. And this is Suhas. Suhas is our machine learning lead and will help us as we go through this. Let me make one thing clear before we get started. You're going to hear about a lot of interesting things today, and we are hiring. So come talk to us if you're interested afterwards. Let's see if I can get this thing going. I guess we will have to use this here. So we are Zalando. Zalando is all about fashion. We love fashion. If somebody went to our website 10 years ago, this is what you would have seen. We started in 2008. We are a 10-year-old company, 5.5 billion euros in revenue today. Started as a very simple online shop. And I think we were selling flip-flops when we started. Today, we are Europe's top online platform for fashion. And all of this, what we do here, this is all driven by tech. We are a tech company. What do we offer today? We offer about 300,000 and counting articles, over 2,000 brands all over the world that we source this from. We have assortment that's local. That means if you buy something in Berlin, you get something that is suited to the tastes, the climate, the kinds of things that people will want here. Private labels as well, 15 private labels. We have a very sophisticated category management, over 500 designers. We even do curated shopping. What that means is we go out and help you figure out what would look good for you. Suhas, you want to just move this thing? Thank you. So what's our strategy? Our strategy is to be a platform, be an enabler. So we work with all those brands that we were talking about, 2,000 plus. We work with consumers. We see what the consumers are looking for. We see what they like. We see what they don't return. We see what they actually keep. And then we connect them with the brands. So we are an enabler. That's what Zalando is. Next, please. And we are a technology company. We dress code. Next one. So I moved here to Berlin from Silicon Valley, having lived in Silicon Valley for almost 20 years. I moved here last year, been here about a year and a half. And what I've realized is working at Zalando is like working at a Silicon Valley startup. Just a big startup with the resources that a Zalando has, and very well funded, but it's innovation all the way around. And we are completely cloud-based. We do have things in the data center, but we are moving a lot of them into the cloud. AWS is our main cloud of choice. And everything that we're using is cutting edge, very scalable. Over 2,000 tech employees right now, 8 international tech locations. Our headquarters are in Berlin. If you are over the East Side Gallery, if you've seen the new Mercedes-Benz arena, the Platz area, those buildings there, most of them are Zalando. So if you come work for us, you'll be sitting there looking out at the tourists on the Berlin Wall and watching the spree. But bottom line is we are innovators. Next, please. So let's talk a little bit about what kind of use cases could be there for machine learning at an online retailer. I will use Zalando as an example, but it's actually exactly the same thing if it's Zalando or a different retailer. So the kinds of things that we would be looking at. First of all, size, right? Am I getting the jacket that's going to sit well on me, that's going to look good on me? Things like search. When I go onto the website and I do a search, is it giving me contextual results? Is it giving me something that makes sense for me? think about buying stock. And when I mean buying stock, think about those 300,000 articles that we were talking about. You have months before somebody actually comes to the website and actually buys something, where you have to actually get that stuff purchased, ordered, delivered into your warehouses and ready to be shipped, so that when you go and buy and say, I want it tomorrow, that thing is there. So all of this buying stock, the supply chain behind it. Personalized marketing. When you go to Facebook, when you go to Google and you do some searches, how do you make sure that you're getting the relevant recommendations for Zalando? Optimizing discounts. So how do you make sure you give customers what they need, including discounts? Gift cards, if you want to give gift cards to somebody, what kind of gift cards would make sense for you? Loyalty programs, and a whole bunch of others. And I'll give you some examples of what we actually do at Zalando. So this is a real screenshot. I took this a few months ago. I had moved from Silicon Valley. I was living out of a suitcase. And I said, dang, I got to make a talk somewhere. I got to go buy a jacket. So I went to the Zalando site, and I did a search for a jacket. So if you see, this is a real screenshot that I saw. If you see that screenshot, everything that you're seeing there is driven by data. And most of it is actually driven by machine learning. It is really a machine learning-driven customer experience. Next, please. What does that mean? So in near real time, recommending to somebody something that will make them happy, something that they will purchase, something that they will keep in the right size, in the right fit, something that they will not want to return, something that they'll be happy with at the quality that they want and at the price that they want, right? And so being able to give them multiple options, that's the work of the recommender. And of course, you know, if you like this thing, you might like these other things as well. How do you recommend other things? Next, please. And then I was only looking for a jacket in that search. But when I looked for that jacket, it didn't just return me jackets. It said, hey, if you're looking for a jacket, maybe you're looking for a tie. Maybe you're looking for a shirt. What color should that shirt be? Maybe trousers, maybe shoes, socks. So how do you complete that look? All of those pieces, that's all driven by machine learning. And of course, behind the scenes, I talked about getting the stock in there. There is a completely invisible set of people behind the scenes who are doing supply chain. What does that mean? It's what do we need to provide? When do we need to provide it? Where do we need to provide it? How much of it should be provided? All of this is driven by machine learning behind the scenes. Now, let's talk a little bit about the technology. So we use today probably every piece of technology in the data science machine learning space that you might have heard of. If it's useful and successful, we probably use it. This is only about 1/5 of the technologies that we use. What I'd like to point out here is, of course, we are heavily an AWS shop today. Spark, we do most of our work with Spark. Our data lake is S3 with a lot of Spark built around it. We use Superset, Presto. The Exasol guys were downstairs. We use Exasol even on AWS. That's what we're trying to do now. But basically, if you've heard of anything in the data space that works well today, we've probably used it and maybe using it in production. Next, please. Let's talk about the machine learning journey. So where does the machine learning journey start? It starts at the very top, which is exploring that data, right? How do you see what is the data that you're looking for? How do you get that data? How do you clean up that data? How do you prepare it so that you can actually do machine learning? And then when you're going to do machine learning, how do you train those models? What are the models that you get? How do you evaluate the models that you really want to use? Once you've done that and scored the models, how do you actually deploy them to production? And it's not done then. When you start running them in production, how do you actually see that it's doing the things that you want it to do? Is it the right model? What changes should you make? Monitor, evaluate, and then the whole journey starts again, right? How do you keep improving these models? So what we found out when we started doing machine learning is that there was really a balance that we had to achieve. And that balance was everybody wanted to do machine learning. If you look on the left-hand side, we had so many new use cases, so many new users, so many new teams that wanted to run machine learning. And if you think about what every one of them needed, they needed cost efficiency. They needed cutting-edge technology with safe metadata, with compliance, with GDPR, and all of these things built into it. And speed of experimentation. Fail fast. If you're going to make a mistake, make that mistake, correct it, come back to the next thing. So very difficult to achieve this balance. if I just draw that pipeline down into a single use case, it's not that hard. What you can do is, yes, you've got a machine learning use case. We typically use notebooks. Some people use some other UIs to create the workflows. And then we do the fetch data, extract the features, prepare that data. And then, of course, train the models, deploy the models, serve, monitor, and then come back, right? Pretty easy for one. Now, if you do a couple, pretty easy for a couple. But what we are actually doing right now is there are literally dozens of teams doing the exact same thing again and again. Most of them on AWS, some on other platforms too. But as soon as you start scaling up, that's when the problem really starts. It becomes really difficult. And so that's when we started looking at what solutions were out there that we could use. One of them was Sagemaker. We did look at many others. We looked at startups. We looked at other big companies. We looked at what they were doing and where they were in their journey. Really, three things that made us decide to use Sagemaker today. So the first one is really that point one up there, which is the ability to really compose training jobs, tuning jobs, and creating these endpoints with ease, create this endpoint that you can call as an API. And also, of course, that Sagemaker was working with a lot of the AWS out-of-the-box algorithms that you could test out things with. Very important. So doing it at scale, doing it with speed, first main thing. The second thing was doing it safely. So being able to understand the metadata that's there, being able to look at it at every stage of that journey. You know, what do you need to do for GDPR? How do you need to make sure that this data is available when you need it? And then, of course, with cost efficiency. So being able to do it in a serverless manner, being able to control, being able to understand how much is being used by who, when, et cetera. All of these really critical things for us. So I gave you a little bit of a picture about why we do machine learning, how we do machine learning, and why we decided to pick Sagemaker as one of our main platforms that we use today in machine learning. But again, this is very early days in this for us. We are just starting that journey, and it's going to become much more interesting, I think, for us. So I think I'm going to ask Suhas, who is our machine learning lead, to walk us through some of the details of how this happened.
Thank you. Thank you, KK. Now, can you hear me?
Yes.
Perfect. So I was just counting the number of use cases that you were speaking in your talk. I think it was around 13 or 14 that you mentioned.
I probably missed about.
Yeah. So probably you get the context of why we introduced something like Sagemaker at Zalando. It's because of the sheer scale at which Zalando operates. And these 13 or 14 use cases that KK was speaking about earlier, it's not just 13 individual projects. It's 13 proper machine learning end-to-end journeys. And these 13 projects are carried out by 13 or 14 teams. And each of these are individually broken down into multiple stages of experimentation and journey, like we saw in the dozens of ML pipelines in picture. So that's why we had this in mind to make research, the machine learning, the actual research that happens in machine learning, because machine learning is about experimentation. That's how you start machine learning. You experiment with data. First, you say, OK, I want to see what happens if I use this data, or what happens if I use another data set, what happens if I use yet another data set. That's how you start. You start understanding what your data is. And this takes time. Understanding data takes time. And then you need to see what features that you need to derive out of this data set. That takes time. Then you need to see what models you have to apply to these features. Also takes time. So the underlying story here is the machine learning journey takes a lot of time. And we want to get rid of all of these unnecessary redundant time in the picture. We want to make things fast, because machine learning should be a commodity that every engineer or every data scientist can do in the company, because the value that we can unlock with machine learning is tremendous. And that is the message. And that is why we picked Sagemaker and the cloud, because of the 3 points that KK was mentioning earlier. It's all about scale. And with scale, we have problems. And the 3 problems that we really want to focus on, we really want to reiterate, is at scale, we still need speed, we still need safety, and we still need cost efficiency. Now, that being said, how many of you in the room already used Sagemaker, just to give me an idea? Pretty good. OK. So I will give you a brief sort of a context before going into. So for those of you who haven't used Sagemaker before, I'll give you a very brief context on what Sagemaker really is for a couple of minutes, and then dive into productionizing ML pipelines at Zalando. So this is I think Vlad can speak better on this, but ideally what Sagemaker provides you is a set of resources. Resources, some of them are persistent resources, and some of them are ephemeral resources. So at the heart of Sagemaker for us, at least for Zalando, is the training job. And the training job represents an experiment of a machine learning journey, in a machine learning journey. And like I said, experimentation is really core to machine learning. And we want to experiment as much as possible before getting that right model into production. So training job, what training job gives you is very simply an interface to launch a training on whatever instance you want, given an algorithm and given a data set. And the algorithm that you feed it either via script or via container, and the data that you feed it is typically via S3 prefix. The second the second real workhorse of Sagemaker for us is the endpoint. Now, once you finish an experiment and once you finish training your model, you need to put that model into production. You need to make sure that the model is being used by a lot of people in the company. You need to make sure that there is maximum return of value for your model. For instance, size recommendations is the first use case that KK was mentioning. Let's say there's a model that was created out of size recommendation. So there is the front-end team that actually, the application team that actually needs to call this size recommendation API. There is Android application, there is an iOS application, there are different experiences that need to call these APIs. So at the core, we want to make these models available to as many use cases as possible, so we enable this kind of a sharing of value to different teams in Zalando. So endpoint is that second workhorse. The first workhorse was training job. The second workhorse is an endpoint. And the endpoint really allows you to pick a model from a training job and wrap it in an API. And that API can be used in any of these applications. The second pattern in an endpoint, what we see is it's not really an endpoint, but a batch transform job. That is a resource that you can use when you do not have a serving or an API kind of a use case, but you really want to say, I have 10 million data sets that I need to score at one single point of time. So I just pass this S3 prefix to the batch transform job. And then what batch transform job does is give you back the score which the model applied to all of this 10 million data sets. And you're just good to go from there. But this talk is on some patterns. So Sagemaker has good docs. Thank you for that. So you can go look it up. I think it's really cool. But what we want to focus on in this talk is how are we taking the functionality and the power of Sagemaker to productionize machine learning pipelines at Zalando with the three things that we were speaking about earlier. So there are some patterns that I would like to talk about today. So this is a very quick visual representation of actually a step function pipeline that is using and orchestrating whatever I spoke about, which is a training job and an endpoint job. And step functions is the key way in which we are translating the machine learning journey onto the real AWS resource here. So what you see there is not all states are represented here. I'm just going to use my mouse. What you see here is a series of states for the machine learning journey. And the states are, so you start a training job, you wait for the training job, and when you're waiting for the training job, you get visual feedback of what's going on. This is step functions again. Then you define your state, what happens after you wait, so you get the status. So if it fails, you handle the failure somehow. If it doesn't fail, you mark it complete. So you say the training job successfully completed. And I would assume that the completion of the training job would somehow result in an artifact stored in S3 somewhere. which is used to create an endpoint deployment. And once you create the endpoint deployment, you pretty much are good to go. And this is a very, very simple end-to-end machine learning journey that only comprises of finish a training, put the model in production. But you can compose multiple training jobs, multiple endpoints, multiple models based on the logic you want. Another quick picture of this. So we are now deeper into the state. The pipeline is running fine, a lot of greens. So if something goes wrong, the color is red. So you see what's going wrong. But now that we saw that flow in step function, what really produced that visual workflow? What was the developer experience like? And how did the developer actually ensure that he sped up this experimentation cycle? So here we focus on simplicity. So machine learning usually is treated in terms of complex resources and artifacts, saying, oh, I have my training job somewhere, I have my data somewhere, I have my distributed cluster somewhere, and I have my compute logic and business logic in GitHub somewhere. So it shouldn't be so complex, so it should be simple. This is a sample project structure that we are trying to put it into production. So that's what we are seeing now. And it's a very simple structure. So you only have 3 kinds of entities here. One is a training job.py, which has some information on how to do a training. One is an endpoint.py, which has some information on how to put your model, that was the output of a training job, into an endpoint deployment. And you have a CloudFormation YAML file, which has some metadata. Primarily, you have a definition of your step function, so which is pretty much your states on how the training job should be handled, if it's failed, and how the training job should trigger more training jobs, or how the training job should lead to endpoint deployment. So you have the state definition, and this is using the Amazon state definition language. And then you have some trigger rules. So often, the pipeline itself should be automated, right? So you have some trigger rules. So here, I would like to take a very quick pause and go back to talking philosophy for 30 seconds. So machine learning is not just about models. That's what we figure. Because models can be retrained, models can be thrown away, models can be reused. But machine learning is really not about data as well. It starts with data, it has models, and it can be used. But the real pattern that is powerful to think about of machine learning is a pipeline. Machine learning is a pipeline. It consists of a journey from start with data to features to models to predictions or observations. So when we say pipeline is the fundamental entity of machine learning, you need a way to interact with these pipelines. So you need to define some operations on these pipelines, like start a pipeline, stop a pipeline, redo a pipeline, and things like these. And then the classic rule, the trigger rule, is one of the trigger rules that we use is CloudWatch, is if a new data set is available in an S3 prefix, we trigger a training job and an endpoint. So it's as simple as that, and that's the design pattern that we want to focus on. And so this design pattern helps us to also say, whenever there's new data, every day, every night, I have the pipeline running safely and securely and deploying a model into production without you having to do really anything. So that is the trigger rule. You usually use CloudWatch, or you could also hook it into other AWS services. Finally, we have, in the CloudFormation itself, you just define roles. Roles for safety, roles on who should be really able to run the pipeline and what kind of AWS resources it should have access to. Of course, then you have your favorite CI/CD configuration, where you want to commit it to, on what rules that you want to put the pipeline in production. Do you want to have 4 eyes? Do you want to have someone give a thumbs up to your deployment? Do you want to have some review? Whatever configuration with Jenkins, Travis, anything you'd want. So this is the structure that we're going with. It's a very simple structure. So you have a way to define your training, you have a way to define your endpoint, and you have some metadata configuration. So that is the first step to speed. The first step to speed for us is simple project structures and simplicity. This is a very quick sneak peek into the code of the training job.py. So I'm just a very quick tidbit is I think I see Elvin sitting here on the stage. He's part of my team at Zalando. So it's just copy-pasted the code from his GitHub from in our Zalando's code base. So it's a very simple code. All we do here is define a handler for the training job. I know it's a little, the font is a little small, but it's just an image. I didn't want to do demos, and my Wi-Fi is switched off. So I'm just going to hover the mouse over and then walk you through it. So we just define some input paths for the data, and define some configuration for the training. We say, I want this instance type, I want this instance count, and that we're getting from the environment of the operating system. And how does the operating system have the environment? Because we committed that in our CI/CD and environment. And then we create a session. Then we create a Sagemaker session, which allows us to interact with Sagemaker. And then here, these two lines here, they're just they're indented in a series of lines, but there are really two lines of code. The first line of code is creating an estimator, and the second line of code is setting hyperparameters for the estimator. And the first line of code, what the estimator really is an interface for the model to be trained. And to this, you can pass in Sagemaker either a container, and you can say, OK, this is my ECR container, or you can just pass a script. So you can just say, with your Lambda, you can just say, I have my training.py, fashionmnist.py, something cool.py, and then you just pass that to your estimator. And then, of course, you give it some configuration. Then you set some hyperparameters. You just say, for this training, I want these hyperparameters, and then you call a fit. The fit, what the fit does from the Sagemaker SDK, the fit is the magic function. It instantiates your instances, does the training, and takes it down. And that's the serverless aspect of the training job. So the fit really gets the data in. And here, I think, we are also using validation data. So it's not just input data, it's also validation data. So you just take that in, do the training, validate it, and then shut the instances down. So that's a very quick sneak peek into the training job.py. So endpoint.py is pretty similar. I'm not going to show that. It's pretty similar, very simple series of steps. You create an endpoint. But what I want to show here very quickly is the one of the patterns that we are following. This is a screenshot from the Lambda console. We define the Lambda here, and this is a Lambda. And from the Lambda console, we have some environment variables. So for instance, one of the patterns that you could just use, and it's a simple pattern, is you could call your training job some experiment ID, timestamp, and a build number. Now, the build number could automatically be suffixed to every training job that you do when you're committing your code to your CI/CD. So it's a very simple pattern that can just ensure that there is sanity in your experimentation. Again, the focus is simplicity. Don't really have to do anything complex. We just follow simplicity. This is a series of environment variables from the serving type. What we do is just mention, oh, by the way, so these are real examples. I didn't want to take fake examples or fake screenshots. But what I've done is I've used a tool and blurred the things out so it looks a little cooler and mysterious. So this is some environment variables for the serving part. Again, very simple stuff and very simple patterns. So you just have a Docker image for your serving on how to really serve this model. And you have some other configuration like what instance count, what instance type, and what is the model name that really resulted in this. So how does this all really look? So all the journey that we looked at so far can be fit into a very simple picture like this. So the developer starts from his console. he has a project, and then he commits this project to Git. And from Git, the 4 files that we saw, the training job.py, endpoint.py, and the 2 YAML files, the YAML file triggers, the CI/CD YAML file triggers the continuous deployment. And this is the pipeline's deployment once. You don't really need to deploy the pipeline every time. And that's the pattern we're going with. So automate machine learning as much as possible, so pipeline should also be automated. So you deploy the pipeline once, and the pipeline itself takes care of retraining the model every night or at any frequency possible. And the deployment really deploys the AWS resources in, and then instantiates the necessary resources. In our case, it spins up the step function, lambdas, and Sagemaker is really the workhorse of this ecosystem. And the resources are created and in production, and you just get the immediate feedback loop from CloudWatch once it's deployed. But then the feedback loop is something that is really important and what I will be focusing on in a moment. But before that, the same slide, again, but with cost efficiency. Not only is this simple, but it is also cost efficient for various reasons. 95% of this is serverless on the picture. So step functions are serverless, lambdas are serverless, Sagemaker trainings are serverless, and you really see how cost efficient the entire pipeline is. So lambdas are triggered when they need to be triggered. The training job gets triggered when it needs to be triggered. And the training job spins up instances and takes it down once it's finished. And then you have a model and you're good to go. So most of our machine learning is serverless. And it's really cost efficient when you have hundreds of pipelines that need to be run. Right. Going back to now, so far, we concentrated on speed and cost efficiency now in a simple slide. But what we will focus on next is safety. So there is this picture that is making rounds, not on the slides, but there is this picture making rounds that machine learning is, I think everyone's seen the picture, it's a very famous picture, that machine learning is hard. We don't really know what's happening. We don't know how to track data. We don't know which model was resulting from which data set. We want to know what really is happening. We want to know how the model was performing. We want to know if there is a particular change in the data set that resulted in change in the model and something adverse is happening. All these kind of questions that you have is really key. So metadata is a key part for all of this. And safety and feedback loop is something that really we want to get right. So with, again, some blurred screenshots. So with Sagemaker, this is very simple for us. Because so when we say machine learning pipeline should be safe and understandable, there are a series of questions that we can ask and we should ask, and that needs to be answered. So things like, when you deploy the pipeline, so this is not the Sagemaker console yet. This is the step functions console. And there are a series of things that you can see here. The first is who really has permission to run the pipeline. So you have an IAM role. And this IAM role was also committed in the CI/CD pipeline. And you have when was the pipeline created, and you have the list of executions. So how many times did the pipeline really run? Did the pipeline run properly, whether it succeeded or failed? And when did each execution happen? So that's the first set of input feedback for you once you start thinking of it as a pipeline. Next, you click on a particular execution. You know what really happened in each step of the pipeline. You know what were the steps for every execution. And then you can also see the Lambda, the CloudWatch logs, and how much time it took for each step. And there's the elapsed time and when really it started or it completed. Then let's say we pick one step from this series of execution, and that is the training job. And the training job is really the heart of the experiment. So this is a screenshot from a training job. So you start to see the metadata here, and then you see why it's really safe. So from the first question, did the training run properly? And did it have anything? Was there any issue with the training? What was the name of the training? When did the training run? And how long did it run? And the 3 minutes here is the amount of time that the instances were spinned up and spun down. And you really are built only for that 3 minutes of time. And who had permissions to run it? So again, the I am role that you committed. And every pipeline has its own permission. So this also gives you the fact that pipelines and training jobs are immutable. So you could also clone your training job and create a new experiment. But we really need every training to be immutable. We don't want to pollute different trainings. And then you want to answer questions like, what kind of instance did the training run on? What exact algorithm was used? And how was the data loaded? Either file or pipe mode that Sagemaker provides. And what exact data was, so you can also define multiple input data configurations. Here there's only training and testing, but you could also define other input data configurations like validation, secondary validation, tertiary validation, and so on. So what exact data was used for training? So this is the S3 prefix. So you really know for which training, which data set was used, so you know what the effect of the model is. So you can go back the story and you can build the story. So there is visibility and lineage for this. What exact data was used for testing again? So was there a discrepancy between the training data and the testing data? Or is there consistency there? You could also start defining things like how you need the training to be monitored. So let's say your training once you're training, you have a training job where you need to really see how the progress is, how the loss is, how the root mean square error is, and how the throughput is. And if it's going good or if it's going bad, you really want to see. So you can define these things, and then you also define your hyperparameters in the bottom. So and this is from the lambda training job.py, what hyperparameters were actually used for the training. And then you know where the exact output model was stored. And this is, again, a fully blurred image of the monitoring for the training job. So you see how was the training actually progressing with all those metrics that you defined while the training is running. So that completes the training, safety of the training part. So you know exactly what happened in all of the use cases. But now for the endpoint, this is a screenshot from an endpoint resource type. So you start seeing things like, is the model in use? So this could be any model that has been put in the endpoint. So you have the model name. So you say, is the model in use? And when was the model deployed? And where is the model deployed? So the URL here is really the URL that you can embed into any application that can be used. And you can just call this API, say, cat, so you can send a picture of a cat or a dog, and then this URL is going to tell you if it's a cat or a dog if you're building a classification model. And then you have what instances are the models deployed on, which model was deployed, and most importantly, what training job resulted in the deployment. So you know every deployment is because of some training. So this is probably the good part of your endpoint deployment. You start seeing immediately how is the model endpoint performing, what was the scale at which your model is operating, and do you need to scale up, or scale down? So that completes the safety part of our journey. So we looked at speed, we looked at cost efficiency, and we looked at safety. Now coming back to the scaling part, the overall overarching scaling part. So like KK was mentioning earlier, we're just starting with machine learning in our central functions team, and we're just starting to support teams with machine learning. And soon after we started, this is the kind of feedback that we get from the scale at which we are operating. So soon after we started, we already have, in the last few days, 2,000 training jobs created. So over 40 hyperparameter tuning jobs created. And I'm assuming the 40 hyperparameter tuning jobs are also responsible for a lot of those training jobs. Then 3 new models were deployed into service just in the last few days. So this is the kind of scale that you can really quickly achieve with the kind of patterns that we spoke about today. So the key message here is machine learning needs to percolate. Machine learning needs to be commoditized, and machine learning needs to be democratized. And to do that, you really need to experiment more. And the key to do that is simplicity and trying to really see how you can scale with simple steps while really understanding what you're doing. So that's pretty much what we had. And like KK mentioned, we are hiring. So you can write to either me or to KK, or we can speak later once this talk is done. That being said, thank you.
Shall we take some questions?
We can open for some questions if anyone has it. We have a few minutes.
Should we just give him a mic or something?
Hello. Yeah, thank you. I'm not that loud. My question was about when you track the experiments and you archive which models you run on which data and what was the outcome, how do you make sure, let's say a few months after this model ran, that this file that you reference in S3 still exists because it's just a reference, or does it actually back up the training and validation data somewhere as well to make sure that you can rerun the model on the same data?
So as long as you have your S3 prefix immutable, you can really just do the training again. Does that sort of answer the question, or?
Not really.
So ideally, so if you want to really redo the training job again, and if you want to make sure that the behavior is the exact same as what you did 4 months back or 5 months back, the only thing that you need to make sure is your data is the same. And for that, you just have an S3 prefix, and you ensure that the S3 prefix really hasn't changed. So you have your data there, and then you have all your training job data there. So you just clone the training job and rerun it, and it's referring to the same data set, so you have a new model in production.
So you have an S3 bucket from which you never delete data, pretty much.
Yeah.
Okay.
Yeah, and it's a general good practice for data lake to make your S3 bucket append only. So you basically don't delete data unless you get to the situations when you have to. But the good practice for data lakes is do append only.
So thanks for the presentation again. So I work as a machine learning engineer in some projects, and I have some data scientists on the project as well. So they handle modeling, and I handle modeling and deployment. And we always have a problem of merging notebook code to production code. How would that fit here? Because it kind of skipped the notebook code part and directly went into code that could be deployed.
Okay, so there are some patterns for this that we follow at Zalando. So experimentation is really Jupyter notebooks. And often we have engineering teams that, so you need some sanity when you're doing experimentation. So ultimately, even from a Jupyter notebook, you can just launch training jobs. So you have Sagemaker notebooks or even any other Jupyter notebooks. So experimentation, so you have a workflow, what I represented here as a set of lambdas, but also the experimentation workflow is just cells in a Jupyter Hub notebook. Right? So you have the first cell where you do something, the second cell where you do something, and the third cell where you do something. So even from a notebook experience, you can just launch tens and thousands of training jobs, and then you can really pick which training job to put it into production. But there is some sanity needed here. So there is some engineering effort that's needed to translate your notebook to a Python file for the production.
Hello, thanks for the talk. I have a question about the data. Is there any way how you can version the data sets? Or so we have our code in GitLab, so that's versioned. But now if you know this model was working very well 2 months ago, but there's an update on the data, is there any kind of versioning system for the data as well that is somehow neatly integrated into this?
So you can use standard data lake practices for something like this. So one of the standard data lake practice is to have date prefixes for your data. So you have, let's say you have a data set about flight journeys or something like this. And then you have S3 flights, DT is equal to today, DT is equal to tomorrow, DT equal to day after tomorrow. So this is one such practice. But there are multiple other practices that you can do to ensure that your data is versioned. And like Vlad was mentioning, in Data Lake, you usually do append to an S3 prefix, so, to the data in an S3 prefix. And of course, S3 also has versioning. This is more, so there are quite a few Data Lake practices that you can look up to do this.
Hi, my concern is you mentioned that the data gets updated with just the dates, but what if your past data is getting changed in some way, like some orders get cancelled and now your sales is changed? So how your model actually understands that part? Do you retrain your model? And if that happens, then, because I did not see that part in these slides.
So again, I think there are a series of good data lake practices for this. So for instance, you can have metadata about your data as well, stored in a Hive table somewhere. So you can also have append-only data structures, but then you can rebuild back your logic, sales logic, or whatever in the future when you're training the model, instead of having to have a mutable data set.
We should, I think. Sorry, go ahead.
No, go ahead. Yeah, but I think generally, if data changes, you need to retrain. That kind of a rule.
Yeah.
So one of the things is to monitor model drift. So to monitor when the data you send for predictions actually differs from the data used for training, and you can apply statistical methods if you preserve your predictions. And that is one of the signals you can use to trigger retraining. So that's one of the patterns how you close the loop between training and inference.
And that can be also a good thing, because that needs to be encouraged, because your model is updated all the time and fresh. And that is the reason we want to think of pipelines, so that every time there's a data set change, you listen to the CloudWatch and you retrain the model.
There's also, I would add, can I just take yours? Yeah, can you hear me? OK. There's also, what you saw here was a silo of what we're doing, right? There's actually a lot more happening that's wider. So for instance, cancellations, return forecasts, things like that. What it actually does is you see, we just talked about machine learning. What's actually happening behind the scenes is there's databases, there's ETLs happening, and they happen on every piece of data that comes in. So what goes in to train these models actually has a lot more data behind the scenes, which is actually taking those things into account as well. So every time you retrain the model, you actually have the benefit of all the other work that has been done in the databases before you even get to this point. Yeah. So it's much wider than what we talked about. This part, very simple, using Sagemaker with AWS has helped us get started pretty quickly. Yeah.
So linking a little bit with what you just said, what it was discussed here, the starting point, we already had some Parquet or CSV files or whatever in S3 split in training and test and so on. So before that, you have all the ETL jobs, but you also have some data engineering, some feature engineering job to do beforehand. Do you follow a similar approach? So how do you do it? Do you version that as well? Do you use also cloud step functions for that? How do you do it?
So we could just say, let's say we have a notebook for feature engineering, and that notebook is committed to GitHub. And this notebook could launch EMR or something like this. And this could be just as a Lambda function, pretty much, that loads the data. So this was the example that I showed, started with a training job. Usually it doesn't start at a training job. Usually your step starts at a feature engineering job, which is basically launching an EMR or some Spark somewhere. And then the output of the features is also stored in S3 usually, or maybe some other store, and then that fits into the training job later.
Yeah, and what also happens behind the scenes is that you never want to be, even though we are at an AWS conference and we really like what we're seeing, you never want to be locked into one technology. So what you're doing behind the scenes is, what we really liked about this is we use many different tools for many different things. Somebody uses Jupyter notebooks, somebody uses Databricks notebooks, somebody uses something else. to do that exploration, feature engineering, et cetera. What we like is you've still got one standard pipeline that you can feed in from any of these into. And then you can leverage the training, the production, and the monitoring, and all the other parts of it. So we want to use open source, we want to use third parties, we want to use AWS, we want to use inner source, and you want to be able to plug them into this entire pipeline. And so, yes, the answer to your question is, yes, we use many different tools, many different ways of doing feature engineering. Notebooks is one of them. Yeah. Other questions? Well, thank you very much for staying on.
Thanks a lot.
Nice job.